In this video, we will discuss about the equivalent concept and n factor calculation for acid, base and salts. So let's start with the law of equivalence. If you have not subscribed the channel, first subscribe the channel so that you can get more videos like this. So what is mean by law of equivalence? According to this law, weight of substance, weight of reactant or product taking part in a chemical reaction is directly proportional to its equivalent mass. So we can say that W by E of each species taking part in the reaction, whether it is reactant or product, will remains constant. So W by E is known as equivalent. W by E is called number of equivalents, or simply we can say that it is equivalent. So equivalent is what? What is equivalent? We can say that equivalent is a number like moles which is equal to W by E. We can have different forms of equivalent, like equivalent weight can be written as equivalent weight can be written as molecular weight or atomic weight divided by n factor. So we can write that W by E is equals to constant. So we can write as W by atomic weight or molecular weight divided by n factor. This will give n into n factor. This will also be this also represent the number of equivalents. Now, because we know that the normality is number of equivalents in 1 liter of solution. So we can write normality as W by E divided by volume in liter. So again, W by E we can write as normality into volume in liter. So normality into volume in liter also represent the number of equivalents. So we can have the three formulas of number of equivalents. First is W by E, which is equal to n into n factor. That will be equal to normality into volume in liter, right? So students are advised to be careful about the equivalents and milli-equivalents. Milli-equivalents and equivalents, as if volume is provided into ml, then n into v ml will represent the milli-equivalents. So this n into v ml is not equal to equivalent. So milli-equivalent will be given as n into v ml. So equivalent, that will be equal to n into v ml divided by 1000. Let's start how we can calculate the n factor of acid and base. N factor of acid and base, how we can calculate? So n factor of acid when reaction is not given. When reaction is not given, will be equal to its basicity. And basicity, what is mean by basicity? Basicity stands for number of replaceable hydrogen. So when reaction is not given, how we can calculate the n factor of acid? So n factor of acid when reaction is not given will be equal to basicity, and basicity is number of replaceable hydrogen. For example, HCl, H2SO4, H3PO4, H3PO3 and H3PO2. If we wish to find the n factor of each acid, then we can write as n factor of HCl is 1, n factor of H2SO4 is 2, n factor of S3PO4 is 3, and n factor of S3PO3 is 2, and n factor of S3PO2 is 1. It is to be noted that we are expecting that n factor of S3PO3 is 3, but it is wrong, and n factor of S3PO2 is 3, which is wrong. It is to be noted that S3PO4 is called orthophosphoric acid. It is called orthophosphoric acid, and S3PO3 is called orthophosphorus acid. Orthophosphorus acid, and this is S3PO2 is called hypophosphorus acid. Hypophosphorus acid. So n factor of these is calculated by drawing the structure of this, because when we will draw the structure we will find the basicity of these. So in case of S3PO4, hydrogen is attached with oxygen atom, so these hydrogens are replaceable hydrogen. So basicity in case of S3PO4 is 3, so n factor is 3. And in case of S3PO3, which is orthophosphorus acid, we can draw the structure like this. So definitely one pH bond is present in this, and 2 replaceable hydrogen in this. Replaceable hydrogen is one which when hydrogen is connected to the electronegative element. So here replaceable hydrogen is 2. So the basicity of orthophosphorus acid is 2. So the n factor is 2. Now in case of hypophosphorus acid, we can draw the structure like this. Definitely here 2 pH bonds are present, and one hydrogen is present which is replaceable. So n factor of S3PO2 will be 1. So this is the way when the reaction is not given we can find out the n factor. One more important example is BOH whole thrice, which is boric acid. It is to be noted that for boric acid we write the n factor is 1, because boric acid when reacts with water, this form BOH whole 4 minus and S3O plus it will give. So boric acid accept the OH minus to form BOH minus, and 1 S3O plus is released. So n factor of boric acid will be equal to 1. So definitely in this case we are considering the reaction of boric acid with the water. So in this case we are considering the n factor as number of replaced hydrogen or H plus. Here we can say that H3O plus. When the reaction is given, how we can calculate the n factor of an acid? For example, when NaOH react with S3PO4, which is orthophosphoric acid, this will give NaH2PO4 plus water. Again, we can write the reaction that 2NaOH plus S3PO4. This will give Na2HPO4 plus water, and again 3NaOH plus S3PO4. This will give Na3PO4 plus 3H2. Since reactions are given, so the n factor of S3PO4 in the first reaction cannot be equal to 3. In this case, we will consider n factor is equals to number of replaced hydrogen atom. In the earlier case, we have discussed the number of replaceable hydrogen atom. In this case, when the reaction is given, we will consider as a replaced hydrogen atom. So in the first reaction, only one hydrogen from the S3PO4 is replaced. So definitely n factor of this will be 1. So the equivalent mass of S3PO4 in this case will be equal to m by 1 if the m is the molecular mass of S3PO4. In the second reaction, 2NaOH plus S3PO4, obviously here 2 hydrogen of S3PO4 is replaced. So this will give disodium hydrogen phosphate and 2 moles of water. So the N factor of S3PO4 in this reaction will be 2. In the same way, we can find the N factor of S3PO4 in the third reaction, as all the 3 hydrogen present in S3PO4 has been replaced. So definitely N factor of this S3PO4 will be 3. If you will notice that in the first or second reaction there is a partial neutralization of base by a polybasic acid which have the basicity more than 1. This is partial neutralization. So this will produce the acidic salt. So this is NaH2PO4, which is called sodium dihydrogen phosphate. This is acidic salt, and again this is disodium hydrogen phosphate. It is also acidic salt. To be noted that acidic salt can react with both acid and base. So as we can also calculate the N factor of acidic salt, which is number of replaceable hydrogen from this. In the same way as we have calculated the N factor of acid, we can also calculate the N factor of base in the same manner when the reaction is given or not. So when the reaction is not given, N factor of base, that will be equal to acidity, that will be equal to number of replaceable OH minus. For example, for NaOH, for CaOH whole twice, for AlOH whole thrice. If the reaction is not given, definitely we can say that the number of replaceable OH minus are 1, 2 and 3 respectively. So the N factor of these will be 1, 2 and 3. One thing more, if the reaction is given, suppose if we wish to find the N factor of CaOH whole twice when it reacts with HCl. So this will form CaOH Cl plus H2O. Definitely the replaced OH is 1. So the N factor of COH whole twice when the reaction is given will be 1. So obviously N factor of base when the reaction is given will be equal to the number of replaced OH minus, and when the reaction is not given we will consider that number of replaceable OH minus. Now how we can calculate the N factor of salt? First we will calculate the N factor of ions. So NF of ions, N factor of ions will be equal to charge present on ion will be the N factor of ion. So if we wish to find the N factor of Cl minus, SO4 minus 2, PO4 minus 3 and FeCN whole 6 minus 4. So the N factor of each species we can calculate the charge, magnitude of charge present on the ions. This will be 1, this will be 2, this will be 3 and this will be 4. Now we will calculate the N factor of salt. N factor of salt, that will be equal to total charge present either on cation or anion. So total charge present either on cation or anion, this will be the N factor of salt. So how we can explain this? Suppose we want to calculate the N factor of NaCl, CaCl2, LF3, Na3PO4, K4, FeCN whole 6, and we can take a common example which is AXBY. So n factor we want to calculate, to definitely total charge present either on cation or anion. To be noted that either on cation or anion. So NaCl will produce Na plus and Cl minus. So definitely total charge present either on cation or anion will be 1. So the n factor of this will be 1. In the case of Ca plus 2, so total charge present on cation will be 2. So n factor is 2. In case of Lf3, the total charge present on aluminum is plus 3. So the n factor is 3. Now in case of Na3PO4, which will produce 3Na plus and PO4 minus 3. So the total charge present on this will be cation will be 3 or anion will be 3. So the n factor will be 3. Now K4 FeCN whole 6, definitely this will give 4K plus FeCN whole 6 minus 4. So the n factor will be 4 because the total charge present either on cation or anion will be 4. So the n factor will be 4. So let's take a salt which is of formula AXBY. So the charge present on the A will be plus Y while B will be minus X. So the total charge present, this will give X A plus Y and Y B minus X. So the total charge present will be XY. How we can calculate the total charge? Suppose this is element X, then we will multiply this by this and by this. This will give the total charge. Suppose we want to calculate the n factor of potassium, which is K2SO4 L2SO4 whole thrice dot 24H2. So if you we will calculate the n factor of this, then the total number of anions will be 4 and n factor in this case will be 8, because total charge present either on cation or anion will be the n factor of salt. Now how we can use the equivalent concept to solve the acid base problem and problem related to the acid base reaction or titration without balancing the reaction. We can start. So let's take first example in which it is given that calculate volume of 1 NH3PO4 required to react with 20 ml 2NCOH whole twice solution. So this is definitely acid base reaction. So simply we can write that equivalent of H3PO4 will be equal to equivalent of CaOH whole twice. It is to be noted that the normality is directly given, so there is no need to find the n factor of this. So definitely we can write directly volume in ml into 1, that will be the equivalent milli-equivalent of H3PO4 because volume is given in ml. So the milli-equivalent of H3PO4 will be equal to the milli-equivalent of CaOH whole twice. This will be equal to 20 into 2. So the V volume of H3PO4 will be 40 ml. In the next question, we required to calculate volume of 1 NH2SO4. Again the normality is given, so no need to convert the no need to find the n factor of this, and the molarity is given. So n factor of ALOH whole thrice will be 3. Simply again we can write that equivalent of H2SO4. Equivalent of H2SO4, yeah, we can say that milli-equivalent of H2SO4 will be equal to the milli-equivalent of LOH whole thrice. So how we can solve this? Volume will be V ml and normality is 1. So 20 is the volume of ALOH thrice into 1 is the molarity and n factor is 3. So this will come normality. So V will be equal to 60 ml. In the next question, calculate the volume of 0.4 m NaOH required. So molarity is given, so the n factor of NaOH will be 1. Required to react with the following mixture. It is given that it is a mixture of acids and it will be completely neutralized by NaOH. So let's suppose that volume of NaOH is V ml for this. So n factor of HCl will be 1 and n factor of H2SO4 will be 2. So we can write this equivalent of HCl plus equivalent of H2SO4, that will be equal to equivalent of NaOH. So what we can write this? Definitely we can simply write this 1 into 1, which is the equivalent of H2SO4, plus 2 into 2, this is equivalent of H2SO4. This will be equal to 0.4 into volume in liter. Directly we will put this. On solving this, what we will get, volume of NaOH required in liter, that will be 12.5 liter. Let's take one more example in which we are performing a reaction of 0.2 m H2SO4 with the base. So this is the basic mixture which is to be neutralized by 0.2 m H2SO4. So definitely for H2SO4 the n factor will be 2, and for COH whole twice n factor will be 2, and for NaOH n factor will be 1. We can use the same equation, that equivalent of NaOH plus equivalent of CaOH whole twice, because it is a acidic mixture that is to be neutralized by, this is the basic mixture which is to be neutralized by H2SO4. So 1 into 1 plus 2 into 2, that will give 2 into 0.2. 2 into 0.2, this will be the normality, and the volume will be in liter. So definitely when you will calculate the volume, again you will get 12.5 liter. Let's take one more example in which it is required to calculate solution containing 4.2 gram of KOH and COH whole twice is neutralized by an acid. It consumes 0.1 equivalent of an acid. Then it is required to calculate the percentage composition. So definitely we can say that this is the 4.2 gram mixture of base, which is KOH and CaOH whole twice. N factor of this KOH will be 1 and N factor of COH whole twice will be 2. So definitely simply we can write the equation that equivalent of acid will be equal to equivalent of KOH plus equivalent of CaOH whole twice, right? So we can write the equation clearly that 0.1 equivalent of acid is given. So let's suppose in the mixture x gram of KOH is present. So definitely the total mass of mixture is 4.2 gram. So COH whole twice present in the mixture will be 4.2 minus x. So what equation we can write for this, that 0.1, that will be equal to x divided by 56, which will be the moles of KOH into 1, which is the equivalent of KOH, plus 4.2 minus x divided by 74, which is the moles of COH whole twice, into 2, which is the n factor of COH whole twice. On solving this, we can calculate the value of x, and what you will get, definitely on solving you will get x equal to 1.47. So we have calculated the amount of KOH in this, so we can find the percentage easily, that 1.47 divided by 4.2 into 100, this will give 35% of KOH in the mixture. You can solve this example, question number 6, in the homework for the practice and give the answer in the comment section. Let's take last example on acid-base reaction by using the equivalent concept. H3PO4, it is given that tribasic acid, as we have discussed earlier, it is orthophosphoric acid with N factor is equals to 3. Now it is given that its one of salt is NaH2PO4. Definitely it is sodium dihydrogen phosphate. Obviously when H3PO4 reacts with the NaOH, this salt is formed by the partial neutralization, and this NaH2PO4 reacts with NaOH it is given in the information. NaOH N factor is 1. It is acid base reaction because it is acidic salt, and acidic salt, as I told you, that it reacts with acid and base both. So N factor will be 2 in this case of sodium dihydrogen phosphate or acidic salt, right? So simply we can write that ki equivalent of NaOH, that will be equal to equivalent of NaH2PO4. So definitely it is 1 into volume in liter, and the equivalent of NaH2PO4, that will be 12 gram is given. So 12 divided by its molecular mass, which will be 120. This will give moles, and N factor of this will be 2, right? So definitely if we wish to find the volume in ml, what we will get, 200 ml will be the correct answer. So thank you very much. In this video we discuss about the complete equivalent concept for the acid base reaction and N factor of acid and bases. To get the more videos on more topics like this and subscribe this. Thank you very much.